Hi, Mr. Simmons here. This is the feedback for the physics work for last week. This is week 3 of lockdown work, so this is P9-3, more about velocity time graphs. So you should have watched the 2 YouTube videos, and I'm going to go through in this video the answers to the questions from the Kerboodle digital textbook, pages 138 and 139. Notice that question 1 is for everyone, questions 2 and 4 are for higher tier students. That's anyone who would like to aim for grade 5 and above. You should have by now received an answer document which looks like this. You can see the title, More About Velocity Time Graphs, and I've put on this answer document the questions, and I've put on the key points and any figures that you need to use to answer the questions, as well as the answers as well. And what I'm going to do is I'm just going to go through this and explain how we've got to these answers. So question 1, match each of the following descriptions 1 to 4 to one of the lines labelled A, B, C and D on the velocity time graph, which is figure 3. So 1, accelerated motion throughout. So we're looking for a line on this graph here which shows acceleration from the beginning to the end of the time. Now notice I've highlighted in the key points, this is taken straight from the textbook, these 3 key points. The gradient of the line on a velocity time graph represents acceleration. If a velocity time graph is a horizontal line, the acceleration is 0. And a positive gradient on a velocity time graph represents positive acceleration, a negative gradient represents deceleration. Now, the gradient means the slope of the line, so a positive gradient is a line that is sloping up, like line B in this case. A negative gradient is a line that is sloping down, like line C, and a horizontal line has a gradient of 0, and that also means its acceleration would be 0. So for accelerated motion throughout, we're looking for a line with a positive gradient throughout, which is line B. For 0 acceleration, we're looking for a horizontal line, which is line A. For accelerated motion, then decelerated motion, we're looking for a line with a positive and then changing to a negative gradient, which is line D, positive and then negative. And then for deceleration throughout, we're looking at line C because it has a negative gradient. It's sloping down from beginning to end. And you can see the answers here just as I've said, B, A, D and C. You get 2 marks for getting all 4 correct. You can give yourself 1 mark if you got 3 out of 4 correct. Okay, so moving on to question 2. Look at figure 3. Now this, you'll see the little h means that this is for higher tier. So this is for grade 5 and above. Identify the line representing the distance that the object travelled. Identify the line representing the object that travelled the furthest distance and the least distance. So we're looking here at this key point. The area under the line on a velocity time graph represents distance travelled. So the line that has the biggest area underneath that line will be the line that shows the object travelling the furthest distance. So if we look here, we can see that the line A going across the top here has the biggest area underneath it. If I were to shade that area, I'll just choose purple to shade it, same as the colour of the line. Then you can see that the area under that line covers over the areas of all of the other lines. So that one has the biggest area out of all of them. Then for the least distance, we need to find the line that's got the smallest area underneath it. So if we look at line C, you can see that the area under this line is smaller than the area underneath any of the other lines on the graph. So that must be the one that travelled the least distance. Then it says which object, B or D, travelled further. So for this one, we have to compare the areas underneath line B and line D. So if we start off by looking at line B, you can see the area under line B is this area here, which I won't shade because I'm going to do this by counting the boxes. So if we start down here, we've got half a box full there, and we've got another half a box full here, so that would count as one box. Then we've got a full box here, so that would count as two boxes. We've got half a box here and another half here, so that would be three boxes. Then we've got 4, 5, 6, 7 and 8. So we've got an area underneath this line, line B, of 8 boxes. So line B is an area of 8 boxes. Okay? So if I just erase that bit of numbering under that, and we look now at line D, because we're comparing which object B or D travelled further. So underneath line D, again what we're doing is we're counting the number of complete boxes. Now that's a little bit more than more than half a box there, and we've got a little bit less than half a box there. So if I were to add that onto this box above, you can see that that would then make one whole box there. So that bit plus this bit here will make one whole box. So if I just count that bit there as 1. Sorry, just changed to a pen. That bit there as 1. So that's this area here plus this area here. We've got another whole box there, which I'll count as 2. We've got 2 slightly less than half boxes here and here. We've got a little bit there as well, which I can add to this box. So if I add that, that will cover that little bit there. So that will make 3 boxes. That will make 4. And then we're left with slightly less than half plus slightly less than half. So that's sort of less than 1 box, even with those 2 added together. That plus that is slightly more than 1 box with those 2 added together. So we could say that maybe this one and this one are approximately 1 more box. So that would be 5 boxes, and this one down here is maybe up to about 1 more box. So that would be 6 boxes. So D is an area of about 6 boxes. So which object B or D travelled further? We're saying that B, because it has an area of 8 boxes. Okay, moving on to question 3, which again is a higher tier question, little h there. So it says, look again at figure 3. Show that the object that produced the data for line A, the horizontal line, travelled a distance of 160 meters. So to do this, we need to calculate the area underneath the line A. Okay, because remember, the area under the line on a velocity time graph represents the distance travelled, and we need to show that that is 160 meters. So to do this, well, the area under line A is just a rectangle, and we just need to work out the 2 sides, multiply them together to get the area. Okay, so in this case, one side is velocity, which is 8 meters per second from 0 to 8. The other side is time, which is 20 seconds from 0 to 20. Okay, now all we need to do therefore to work out the area is multiply those 2 together. So we just get 8 times 20 equals 160 meters. Okay. Then it says, determine the distance travelled by object B. Now B is a triangle, so this is slightly more complicated. We need to use the mathematical formula to work out the area of a triangle, which is that the area of the triangle is half times the base of the triangle times the height of the triangle. Okay, and in this case it's going to be a half times the base was 20 seconds times the height was 8 So I'll just confirm that just by showing you here. So the base is time going from 0 to 20. The height, line B, goes up from 0 to 8 at the top. Okay, so half times 20 times 8. Well, a half times 20 is just 10, and 10 times 8 is 80. So the area under that line is 80, and its distance, so it's in meters. So you can see here the answers again that I've just explained to you. Moving on to question 4, look again at the graph in figure 3. Calculate the distance travelled by object C. So C again is just a triangle. The base again is 20. The height this time is 4. So for this one, it's just our half times base times height again, but this time it's a half times the base, which is 20, times the height, which is 4. Half times 20 is 10, times 4 is 40 meters. So the area underneath that line, representing the distance travelled by the object for C, is just 40 meters. So now we need to calculate the difference in the distances travelled by A and D. So looking at the graph, we've got line A there and line D there. Now we haven't actually calculated the distance travelled for line D yet. We worked out the distance travelled for line A with the first part of question 3, which we found was 160 metres. Now we need to work out the distance travelled for line D, which is the area underneath that. Now you can see that line D is effectively two triangles. If I just imagine drawing a line down the middle here, then you can see that I've got two triangles there. I've got one triangle here on the left, and I'll just shade that to show you that's one triangle there, and then I've got another triangle on the right, which I'll just show a different colour. So I need to work out the area of these two triangles and then add them together. So if we look at the area of triangle A, it's half times base times height, so it's a half times the base, which is 10. So the area is a half times 10 times 6. So a half times 10 is just 5 times 6, so 5 times 6 is 30 meters, and we had two triangles to work that out for, so all we need to do is multiply that then by 2, and that will give us an area of 60 meters. So that means that the area underneath D is the area of this triangle plus the area of this triangle, which we've just worked out is 60 meters. So if we look down here at the answers, so we've got difference then between 160 meters and 60 meters is 100. So it's saying calculate the difference in the distances travelled by A and D. So A was 160 meters, D we've just worked out is 60 meters, so the difference in the distances is 160 minus 60, which gives us 100 meters.